right, so here are some applications of it. So a manufacturer has found that the marginal cost of a certain product is given by this. So this is our rates of change in cost per unit. When Q units have been produced, the total cost of producing the first 2 units is $900. What is the total cost of producing the first 5 units? So what we're going to be doing is taking all that info that's given and rewriting it. So we know our C prime of Q, which is our marginal cost, is equal to 3Q squared minus 60Q plus 400. And you can tell that's our rate because it's dollars per unit. It also says marginal cost. Now the total cost is our C. So what they're saying is C of 2 is equal to 900. They're giving us 2 units, $900. They're giving us our point. So you can see it's just what we've already done. We're going to create our original function by taking the antiderivative, which will give us a constant, and then using the point to find that constant. Okay, so we now know that C of Q would equal Q cubed and 3, and we bring down the 3. Still taking it slow just in case. And that's Q squared, put a 2 there, bring down the 60. If you're pretty quick at it, then just go for it. And then plus C. So this would now be Q cubed minus 30Q squared plus 400Q plus C. And again, we always want to double check to make sure it's correct. So that would become 3Q squared, 60Q, and 400, and 0 checks perfectly. So now if we plug in 2, we should get 900. So 2 to the 8th minus 2 cubed, I'm writing the answer. 2 squared plus 400 times 2 plus C. So plugging the right side in our calculator, we get that is equal to 688. Oops, wrong color. Plus C equals 900. And now a quick subtraction, and we've got our C. So that would give us 212. So now we have our C, and so we can come back up and now do part 2. So our C of Q is equal to Q cubed minus 30Q squared plus 400Q plus 212. And we already checked the derivative, so now we just have to make sure that that is correct. And plugging it in our calculator, it says it's 900. That checks perfectly. All right, now we can actually use it for what we're looking for. So it says, what is the total cost of producing the first 5 units? So if we take our function and we plug in 5, it'll tell us the total cost of producing the first 5 units. And that gives us $1,587. So $1,587 is the cost for the first 5 units. All right, so by using the antiderivative and a point, we're allowed to find the actual cost function and then work backwards. Okay, a particle, I know you guys love these. A particle is moving with a given velocity, and so what we want to do is find the position function. So if you remember to take the derivative, we get the velocity. So if we take the antiderivative, we're going to get our position function. So the antiderivative then would be t, and we add 1, divide by 3, put a 1, minus, and I got to rewrite that one in terms of t. So let me move it down. I need to make it into an exponent. So we get v of t equals t squared minus 3t to the half. Okay, so now we take that t, we add 1, so that would be 3 halves. Remember, we're taking 2, adding it to 1, so 2 plus 1 is 3, it's 3 halves. And then we got to take this and put the reciprocal in front. So 2/3, and then we bring down the 3. We got to finish it off with a little plus c. All right, so we have 1/3 t cubed minus, and then this is 2. I don't need a denominator anymore, so 2 t to the 3 halves. So we're going to leave it as an exponent right now until we finish, and then we'll convert it back. plus c, and then s of t. And then we know that s of 4 is 8. So what they're doing is giving you a position, a location, and then that'll allow us to find our constant. So if I plug in 4, I can then find c. So plugging in our calculator gives us 16/3. So we have, oops, wrong color again. 8 equals 16/3 plus c. And so if we subtract that over, it'll allow us to see our constant. So we take our calculator and we do 8 minus, and then go back up and grab it, hit enter, and it's 8/3 equals RC. And so now we can write our position function for the particle. So S of t is equal to 1/3 t cubed minus 2, and now we'll rewrite it, plus 8/3. And you can take out a t if you want. Get a little tricky here. Minus 2t square root of t plus 8/3. Your choice on the final form. But there you have it. So applications of antiderivatives is really nothing new. All you're going to be doing for these problems is doing what you've done with the previous problems, but they're just going to be in a word problem form.